This video demonstrates how to use the FAIRINO robot as a Modbus TCP slave. First, let's go to the calling interface and create a new program. Open the Modbus TCP settings screen and select Slave Settings. The Modbus TCP robot slave for collaborative robots supports connecting to only one master. It features 128 coils, 128 discrete inputs, 60 for holding registers, and 60 for input registers. The data types for holding registers and input registers include unsigned, signed, and floating point types. Certain Modbus TCP slave input register addresses are specifically reserved for reporting information such as the robot's current joint positions and movement speeds. For specific definitions, please refer to the Modbus TCP slave address mapping table. Certain register addresses are reserved for controlling the robot's start, stop, procedures, configuring the control box's digital outputs, and other functions. Open the Modbus TCP configuration interface. Click Slave Settings. Enter the robot slave's IP address, port number, and slave number, where IP refers to the robot slave IP address. The robot has two network ports, one on the teach pendant end, one on the control cabinet. The IP addresses for the two ports are different. Enter the correct IP address based on the network port used to connect the robot slave to the external device. After changing the Modbus TCP slave IP address, port number, or slave number, you must restart the robot for the changes to take effect. As a slave device, the robot needs to connect to an external master device. In this video, we use Modbus Pole software to simulate the external master device. Open Modbus Pole, click Connection, Connect, and select TCP, IP. Enter the FAIRINO robot's Ethernet IP address, click OK, and return to the web app. A green connection status indicates a successful connection. First, we will demonstrate read in write operations for the slave's DI discrete inputs and DO solenoids. Click the Modbus communication command, select the slave station, and choose digital output. Select DO0, enter 2 for the number of registers and 1 for the register values. Click write and add. Select numeric input, select DI0, enter 2, then click add and apply. Assign the read DI values to variables A and B. Save the program after adding the query variable directive. In Modbus Pole, select Mobile 1, then click Setup, Read Definition. Slave ID is 1. Select function code O to read discrete inputs. The starting address for the robots for registers is 100. The address is 100, and the quantity is 10. Click OK. Create a new MB Pole 2 and click Setup, Read Definition. Select function code O1, set the address to 100, and click OK. Set MB Pole to addresses 100 and 101 to on. Return to the robot interface. At this point, the address values for DI0 and DI1 are 1. Run the program. The address values of DO0 and DO1 become 1. The address of MB Pole 1, 100, and 101 also becomes 1. In the robot printing interface, the variables A and B are displayed as 1. Next, we will demonstrate read in write operations for unsigned AI and AO. Click the Modbus command, select the slave station, choose analog output, select AO0, set the number of registers to 2, set the register values to 11, 12, click write and add, select analog input, select AIO, enter 2 for the number of registers, and click add and apply. Assign the read AI value to variables A and B. Save the program after adding the query variable directive. Modify the MB Pole 1 settings. Select function code O4, set the address to 100, set the quantity to 10, and click OK. Select MB Pole 2, set the function code to O3 and the address to 100, click OK. Set the addresses 100 and 101 of MB Pole 2 to 13 and 14, respectively. Run the program and refresh the Modbus TCP settings. The address values for AO0 and AO1 change to 11 and 12. MB Pole 1 address 100,101 also becomes 11, 12. In the robot's print interface, the variables A and B are displayed as 13 and 14. Next, we will demonstrate read operations for the symbols IA and AO. Select the Modbus command, select the slave station, click Analog Output, select AL16, set the number of registers to 2, and the register values to -11, -12. Click Write and Add. Select Analog Input, select AI16, enter 2 for the number of registers, and click Add and Apply. Assign the read AI values to variables A and B. Save the program after adding the query variable statement. Added MB port 1, select function code 04, set the address to 110, and click OK. Select MB port 2, set the function code to 03, set the address to 110, set the quantity to 10, and click OK. Set the addresses 116 and 117 of the MB port to -13 and -14. Return to the robot interface. The addresses for AI16 and AI17 are -13 and -14. Run the program to refresh the Modbus TCP settings. The address values for AL16 and AL17 will change to -11 and -12. The addresses 116 and 117 for MB port 1 have also changed to -11 and -12. In the robot's print interface, the variables A and B are displayed as -13 and -14. Next, we will demonstrate read-write operations for floating point AI and AO. Click the Modbus command, select the slave station and analog output. Select AL32, set the number of registers to 2. Set the register values to -11.5 and 12.5. Click Write and Add. Select Analog Input. Select AI32. Enter 2 for the number of registers, and click Add and Apply. Assign the read AI values to variables A and B. Save the program after adding the query variable statement. Select MB port 1. Set the function code to 04. Set the address to 130. Set the display to float inverse, and click OK. Modify MB port 2. Select function code 03. Set the address to 130. Set the display to float inverse, and click OK. Set the values of MB port to addresses 132 and 134 to 13.5 and 14.5. Return to the robot interface. At this point, the values for addresses AI32 and AI33 are 13.5 and 14.5. Run the program. The values of addresses AL32 and AL33 change to 11.5 and 12.5. The MB port 1 addresses 132 and 134 also change to -11.5 and 12.5. In the robot's print interface, the variables A and B are displayed as 13.5 and 14.5. Finally, we will demonstrate how to use the wait for digital input and wait for analog input commands. Select the Modbus command, select the slave station, and wait for the digital input to be set. Select DIO, wait for the state to be true, timeout 5000 milliseconds. Select the wait for analog input setting. Select AI0 and set the wait condition to greater than. Set the register value to 1, the timeout to 5000 milliseconds, and click Add. Add the corresponding digital input and analog input instructions. Assign values to variables A and B and add a query statement. Save the program. The program's logic is to print the variable if the conditions are met within 5 seconds. Otherwise, it will report an error and stop. Select MB port 1. Set the function code to 01 and the address to 100. Click OK. Set address 100 to on. Select MB port 2. Set the function code to 03 and the address to 100. Click OK. Set address 100 to 2. Return to the robot interface. The address values for DIO and AIO are 1 and 2. Run the program and check the values of variables A and B. That concludes our overview of the FAIRINO robot as a Modbus TCP slave. Thank you for watching.